Okay, so I recorded this session. So we're going to do like a 1 hour session. So if you have any question, you can just uh, put in the chat box ataupun you can just unmute yourself. It's okay. Okay, so maybe Zahid hari tu dah dengar. Adina pun dah lama tak dengar gambar kan. Okay, so today I'm going to talk a bit on the XML guide. Okay, kalau you guys notice dalam inside your DualSPHysics 5.0, okay, ada folder bin, folder document, folder example, folder SRC, SRC extra, and multiple face. Okay, so inside the bin ada two folder, Linux ke Linux and Windows. Okay, for those yang nak guna Linux pun boleh, yang nak guna Windows pun okay. So dalam Windows ni ada all the packages, the executable files. So for those yang buat open source, maybe you dah biasa dengan this executable files ni. Maksud dia from the main file, kalau orang tu guna, if they use C++ or Fortran ke, they will compile the file and they make it as acuan, the executable file. So you don't need to run from the coding itself. You just jadikan dia acuan like a baking punya template tu. So the rest you just put parameters in saja. The process will be done by this executable file. So kat sini lah dia ada CPU, ada generate case, gen case, measuring tool, all this kita akan go through lah. So dalam Windows ni adalah all the main software. So kalau tu yang pakai Delft ke XBish lah kot. XBish pun ada macam ni juga. They separate. You just need to call the template. Okay, so dalam dokumen, you ada guides, help, XML format. So ada guides, all the PDF file dalam ni. Okay, and then help, kalau you tak sure how to write, because all the inputs, kalau macam, I'm not sure Mike tulis input dalam mana, but kalau dalam XBish ke apa ke, dia akan tulis dalam text file kan. Yang ni dia akan tulis dalam XML file. XML file, the inputs dia. For the physics, all will be written in the form of XML file. And then kalau tu saya tak tahu lagi, dia kat sini dia tunjuk all the helps. So today, kalau you guys go into the guides, under the XML guide 5.0, yang lain tak tengok tak apa, because dia orang dah advance lah, dia orang dah buat dengan collaboration with Chrono and outlet, multi-phase. Multi-phase ni kalau you nak ada oil ke, different density, kan, you nak create different phase of water, air masin ke, air fresh water ke. Mike boleh ke buat fresh water dengan salt water? Intrusion, boleh kan? Yang biasa pakai mic, Zahid lah.
Setakat yang saya belajar lagi ni, saya ada dengar juga orang buat pasal tu untuk fresh water ke salt water kan, daripada river, sorry. Pernah juga dengar pasal tu. Tapi saya tak pernah try lagi ya.
Tak pernah try lagi. Yes, so because Mike ni dia well known because dia company yang besar, dia dah establish commercial. So maybe dia orang ada, tapi mungkin kena explore tu lah. So untuk physics pun you can do multi-phase punya different flow dan nak different density of fresh water ke salt water ke oil ke pun they can do multi phase punya. So going to the input file, this is the body of the DualSPHysics. Kita can create our own case using the XML punya file. Okay, XML punya file. Okay, ni dah banyak lah. Tapi kita akan go through yang mana yang penting saja, iaitu the general workflow of the DualSPHysics. Okay, so DualSPHysics, if you can look, nak contoh. Okay, ada pre-processing and the processing and the post-processing. Okay, so pre-processing dia dipanggil gen keys, order all aka generate keys. This is where you will generate your case. Okay, you generate the setup. Maksudnya you put dalam XML file. This is the XML file. Okay. Dalam XML file ni you boleh panggil any object ni lah. Kalau you ada very complicated object, for example you do dalam AutoCAD, okay, you call dalam you punya initial case definition ni .xml, and then it will generate the setup for you. From that you akan ada keys.xml, binary files, semua tak apa, nanti jangan risau. You don't have to understand anything. As long as you know the generate case, it will generate the setup for you. And then this output from your generate case will be the input for DualSPHysics punya executable file .exe. So dia panggil the executable file, they will run all based on this input, and then dia akan keluarkan all the output dalam binary file juga. And then you notice dia tulis part sini. Part ni meaning that every time step dia akan save in one part. Contohnya you ada 10 second, okay, and you kata every 1 second you save in one file. So part tu akan ada berapa banyak? Akan ada 10 parts of, because you run 10 second of simulation. Ada part 1, part 2, part 3, part 4, sampai part 10. Sebab apa? Dia have every time step dia run, dia kira every interaction inside your domain. So dia akan save in one binary file. It's very heavy, and the reason why they do like this, because this is your main output. Okay, all the data dalam here. So meaning that the post processing you nak extract you nak extract the free surface, you want to extract the velocity, you want to extract the pressure, all can be done separately. You can cherry pick from the main output here. So as long as you keep this, you can always extract the data back. Contohnya kalau this is what happened to me, because it's heavy your computer when you run, especially 3-dimensional. So sometimes I don't keep the post-processing file. I only keep the main output file. So every time I need something, I just run again the post-processing, depending on what information I want. Because if you keep running everything, berat sangat. That's very heavy. If you want to run 10 seconds, kalau you nak run for 30 seconds, for 1 minute, habis dia punya external disk tu. Penuh dengan 1 terabyte tu pun penuh.
Doktor?
Yes?
Kalau macam dekat pre-processing tu, kita dah boleh set up ke macam kita nak letak kita punya measurement pressure ke, ataupun macam ketinggian ombak kita nak set up untuk model set up, kita kena set up kat pre-processing ke dekat post-processing?
Dekat pre-processing.
Pre-processing.
Okay. Yang post-processing ni, you more to what the result of the interaction. Contoh, for example, we have the measure tool here where you can extract the pressure, velocity, height, acceleration. So maybe in the pre-processing, you decide, okay, you not put height 1.0. So the wave coming from your right hand side to the left hand side. Tapi you're not sure once it reach your left hand side, what will be the height at that time because of the bathymetry and morphology yang the wave to being influenced by. So you can check using the measure tool at that particular place, location, and at that particular time. You can put a point there, you can track the wave height coming in, berapa tinggi. So pressure pun you can track if you put the probe there. Contohnya macam kita buat for the Tok Jembal and the seberang kaki, wave coming in from the right and then hitting the structure on the left hand side. So you can put the probe on the structure or near the structure, so you can estimate the pressure. And also you can estimate the vertical, not just macam at one point je, but also at the vertical point. You can put points vertically at each onto the structure, so they can estimate at each level vertically. Isosurface ni, it's more on visualize, nak bagi nampak realistic, macam I show to you yang using YouTube tu, I've shown you YouTube tu, dia nampak macam realistic tu. That is using the isosurface. Dia akan interpolate the free surface bagi cantik. Okay. And then ada boundary. Ini boundary, kalau you have a boundary macam you nak put buoy ke, floating structure ke, perahu ke, moving structure ke, so dia we can use this post processing ni. Especially if you want to focus on the structure je. Macam kalau you put a boat there, okay, you tak nak tengok pun air ke apa ke, you just nak focus to the boat tu je, so you can extract only the boat out. So that's DualSPHysics ni is more to wave and structure, not fluid and structure lah, fluid and structure. And last kali, of course, you have the fluid. If you don't want to include the structure part, you just want to focus only on the fluid part, you can extract the fluid part saja, part BTK. And it's safe in BTK file because BTK file can be handled by a lot of software, and the one that they use is ParaView. I think TechPlot pun can use and visualize the output. Okay, so I think that is introduction of the flow itself. Any question on that? Right. Buka chat. Okay, good morning. Okay, so everyone is okay with that? If okay, then I can continue. Okay, so no question, I continue. I should proceed. Okay, so we go one by one right now. We go from the generate case. Here we have the gen case here, the generate case. So you can see in the blue box here, created by the users. Data for moving boundaries, data of forces exerted on fluid. Okay, this one you don't have to worry. This one kalau you need to have contohnya numerical tank, they need something to push the fluid, then they akan put in here. Okay, so kat sini yang paling penting adalah this one, case binary fault. Sebab apa? Binary file ni dia ada all the particle at initial instant. Maksudnya if you have a box tu akan di-transform into discrete particles. You punya box dia dekat sini, you put your box here, you put your coastal defense punya bentuk, and then the generate case ni will transform your object into a discrete particle data, and every particle tu ada their own data dia punya location kat mana, dia punya initial pressure dia, initial velocity dia, everything will be transformed inside here, and then will be processed inside DualSPHysics. So here part head ni basic information. Ini tak penting pun, tapi adalah, kena adalah, tapi just additional file lah. Floating ni, everything yang floating object will be inside here, part float. Ni particle data, as I mentioned before, output time. So dia, it depends on how many output you have, you ada berapa banyak part. 10 second, kalau you kata every 1 second save, so ada 10 second, 10 parts. Yang ni macam biasa summary, I think every simulation dia akan ada either block ke summary ke, in order for you to if there's an error while running the simulation, so you can check in the run out kat mana error tu. Yang ni binary file excluded particle during simulation, because when you do, because it's very good, the DualSPHysics is good with deformation of free surface, slamming, sloshing. So sometimes this slam kan slosh ke, the wave overtopping, the particle tu excluded, keluar daripada domain. So keluar dari domain pun dia akan track berapa banyak yang keluar daripada domain. Okay, so I think this one sama je. Binary file, sebab apa they use binary file .bi4, they consume 6 times less memory than format. So kalau you save dalam format, jadi bigger dia punya file. And then dia writing dia pun faster, and dia ada double precision. Maksudnya the dot, maksudnya after the dot tu, you can read up to 4 times lepas dot tu, double precision. Kalau macam you, because apa, when you punya resolution to become very small, you really need the double precision tu, because one particle kalau 0.1, another particle 0.1 pun it's very hard for the computer to distinguish. It must be 0.1, 2, 3, apa ke, and then another particle yang closer nearby 0.1, 2, 4, 5, sikit je beza, tapi it's better to have double precision. Okay. BTK sebab apa pakai? Dia boleh macam-macam visualization punya application. Okay, so this is what the XML file look like. Okay, if you open one of the example in the example folder, you should focus only on the main saja, because the rest ni is a bit specific case. Macam chrono, in the upload, mooring semua ni, dia phase, liquid, gas, Newtonian ni, dia try for different specific case. Yang main ni adalah more general case. Okay, so if you open number 1 then break, okay, you can see inside here is where is the XML file? This is the X dot, the definition, define, define keys dot XML. And then dia ada bagi actually it's quite good because dalam every example dia bagi kat you everything. Okay, for example everything, dia bagi kat you the PDF, you can always read apa case dia tengah buat. Dia bagi tahu okay, for this one dia nak buat dam break. Maksudnya kalau ada dam, macam mana wave impact to the dam itself. And water engineering lah, tapi boleh je, sama je. Okay, and then dia bagi tahu the result here. You can see MP4, the results. Okay, what can you expect from the simulation? So here, what the output that they will see is the pressure on the structure lah. That is the reason why they do this simulation. Dia orang tak tengok on the from the perspective of coastal tu, macam air gerak macam mana, monsoon ke apa ke dia, but they only interested on the impact to the structure je. Macam kita kalau photos yang buat coastal defense, mana bagus lah. So that you can simulate different scenario of wave, high, macam mana pergerakan macam mana, and during different season ke, sea level macam mana, the mean level, sea level, and then you just release je, and then they can hit this structure, so you boleh detect at this structure ni berapa banyak impact dia. Then you can compare different time, different scenario, and you can compare dengan threshold. Okay. Ini apa? Ni 2D, tadi 3D, ni 2D. So you can see ada particle yang terkeluar, particle that going out from the domain. Ni is sloshing punya dam break lah, macam sloshing lah. Kalau case macam lori bawa air, kalau bawa minyak kan dia bergerak banyak, and how the water inside the lorry tu dia nak minimize kan dia punya pergerakan dia. So this part of some simulation that need to be done lah. But ini similar juga, kalau meaning that dia ada langgar, and you can see velocity macam mana, pressure macam mana the area. Okay, so kat sini dia bagi batch file as well. You can see dia bagi CPU and GPU, CPU, GPU, CPU, GPU, and then batch file for Windows and SH file shell for Linux. Meaning kalau you tak nak pening kepala, you delete je lah this one. You just copy paste another folder khas for your practice. Yang mana yang tak relevan, buang. Tak relevan, kalau tak pakai Linux, buang. So yang ni dia bagi eksperimen punya data for you to compare, to validate. Dia orang tanya, betul ke DualSPHysics ni apa ni, how do you validate? So actually dia orang buat banyak dah validation from dia punya example in order for them to make sure that the physics tu model very well. So it's maksudnya kalau you betul-betul model the fluid punya karakteristik tu, kalau dia interact dengan apa-apa pun, of course dia akan sama je lah dengan air yang sebenar. Okay, so ada 2D sini dengan ada uh, 3D. So ni 3D, yang ni 3D, yang ni 2D. Okay. Yang ni kat mana dia nak cari pressure dia, point pressure dengan point velocity, pressure probe. Tapi nantilah yang tu. So if we open the XML file using edit notepad++, okay. You can use notepad as well, tapi takut pening Itu dia ni, at least ada color. So the color can help very well. Okay, setakat tu okay. Okay, so setakat tu okay. So you can see here is the similar. This is from the PDF and this one is from the XML file. Okay. So the main structure dia divide into section. Okay. These all the here you see the case definition and also execution. There are two here. Case open, case close, case definition and execution. Kalau kita tengok execution kita pening. Execution ni maksudnya parameter apa yang dia guna. Definition ni, definition dia the gravity. You akan tengok dekat sini. Gravity, apa benda, material dia pakai, geometry macam mana, define, definition, and execution ni more to macam how to execute dia. Masa berapa lama, kalau dia ada any viscosity treatment ke, density different ke, time maximum, time out berapa, position dia macam mana. So for those awal-awal kita just follow the default saja. Okay, so kita tengok dulu case definition, the first one. Definition, okay. So this all the constant needed dalam SPH. And then dia ada MK, okay, MK configuration. Kalau MK ni dia more to if you have a different object dalam tu, you ada fluid and then you ada two breakwaters, for example. How you nak differentiate these two breakwaters? So they put MK. MK tu is a level. Sama ada one breakwater tu MK1, second one is MK2. So if you nak extract, you kata MK2 only, then they know how that they only will extract from the second breakwater. Okay, and then geometry. Okay, geometry is either you can draw yourself, kalau simple je lah. Triangle ke rectangular ke. But kalau yang difficult, then you need the help of pre-CAD. Maksudnya, kalau you ada design yang kompleks macam the rebatment, you need to translate into the pre-CAD and then read dalam ni. So nanti kita baca simple dulu, kita lukis 4 segi je dulu. Initial dia biasalah benda yang initial point dia kat mana, start point dia kat mana. So kalau tengok dekat sini, yang lain semua tak apa, jangan sentuh. The row ni benda yang biasalah, density of fluid 1000. Okay, maximum speed water tak apa, tak kisah. Maximum system speed ni pun tak kisah. Coefficient sound tak payah, tak apa. Yang mana tak tahu tak apa. Smoothing length tak payah. Smoothing length ni one dia punya H tu untuk dia interact with neighboring particle. Yang ni tak payah. Okay, yang ni tak apa. Constant definition tak perlu risau, tak apa. Okay. Boundary count. Boundary count tak apa nanti. Yang penting adalah tengok dekat geometri ni. Kat sini DP ni is your initial point, resolution ni. Dia macam when you do the mesh base lah, mesh base satu sel besar berapa. So DP ni is your initial point. Dia akan bahagikan, contoh kalau 10 meter, 10 meter bahagi 0.0085. And then dia akan dapat berapa ribu particles. Unit dia dalam meter. Okay. Point minimum ni, kita tengok point. Kita terang sini dulu. Tak payah kot. Yang ni, yang tadi tu, yang atas tu, ni cara dia define particle lah. Ni gravity, speed system, sound. Okay. Sekejap ya. So ni configuration dia. Yang tadi tu MK configuration tadi, MK configuration. MK tu dia nak define order of objects. Tapi kalau tak ada banyak, tak apa pun. Tak apa, yang ni tak dulu. Okay, yang ni penting. Okay. Definition ni kat sini, DP ni is your initial particle. In this case 0.05, dalam here dan break 0.0085 meter. Okay. Point minimum ni is this point. Ini waktu dia nak create domain, maksudnya what is your domain? Bukan domain of your model. Domain model you akan duduk inside this domain. Logik dia. So kat sini dia ada point minimum, dia akan buat sini minus 0.05. Maksudnya from 0, kalau you nak put your first model tu dekat 0, so you letaklah domain you belakang sikit. So dia kata note that particles are only created within this domain. Once particle created have been created, the dimension of the domain calculated again starting from minimum and maximum position. Okay. So maximum hujung sini. Kalau you nak pakai 2D, you just bagi samakan saja dia punya Y. So dia akan ambil X sini, Y 0.1 and Z minus 0.05 sini, and then dia akan ambil sini. Tapi sebabkan Y dia sama, dia akan jadi 2D. Yang ni case dia, Y dia tak sama, dia 3D. Sekejap saya tengokkan lagi chat in case. They finish. Doctor, how do you want to know the exact size of breakwater? That is the reason. Okay. Dia, in our case, for example, I think the best thing is for you to just first estimate the. It's better to start from a simple case and then you move up the complexity. Maksudnya macam kalau for case Yun, you kata nak tahu ni, maybe you can tengok kat Google ke apa, tengok just besar dia and then you simplify bentuk dia dan jadikan dia sebagai segi empat gitu. Tak perlu nak buat dia bentuk breakwater tu. And then once you dah dapat the idea of it, or you use a simplified shape and then baru move to a complex shape. So starting tu better guna simple shape. Definition point okay tak? Sebab the practice untuk kita nak buat simulation ni, jangan start dengan benda yang kompleks. Start dengan simple. You can start 2D dulu. You ambil you tahu dia punya lebar macam mana, tinggi dia macam mana, slope dia ke macam mana, and then you assume that this is what this is a simplified version of the breakwater. So what we're trying to do is we try to combine with the different scenario to see first, and then orang actually will accept je, because people know that you only do a simplified version like, of 2D. Jangan terus jump 3D complex structure. So definition point akan berlainan ikut case study ke? Yes. Kalau you macam nak pakai besar, kalau you contohnya nak pakai 50 meter, janganlah letak definition point kecil sangat. Mampus dia beribu-ribu kan. Kau letaklah 0.1 ke 0.05. Tapi kalau case dia ni kecil dia pakai 2 je point maximum dia, so they can go smaller resolution dia. Resolution tu you can try and error sebab dia ada satu lagi yang dipanggil variable distribution. Maksudnya you boleh kecilkan kat bahagian yang you nak dan juga coarser macam buat mesh. Yang tu saya tengah explore ni. Okay. Lepas tu sebenarnya ni dia kata disebabkan 2D configuration ni can be generated imposing the same value along Y. So imposing the same value along Y, you can get a 2D. Okay. And then kita pergi kepada geometry sini, command. Several command ni boleh kita create. Ini in case you nak buat geometry simple je. Kita nasihatkan kalau boleh start with simple geometry and then you increase the complexity. Okay, first dia akan create you can create using drawing. Kat sini dia kata draw box. Creation of fluid particle, box of water. So dia set MK fluid. Yang ni tak payah ubah pun tak apa. Maksudnya dia set the MK fluid tu, MK tu equal to 0. Maksudnya you nak refer the fluid tu nanti the MK punya level tu is 0. Full meaning that dia akan put everything full. Ada setengah as macam volume. So the draw box solid, the start draw box at 0, coordinate 0, 0, 0 until the size of 0.4, tinggi 0.3, lebar 0.67. In this case, fluid dia. MK fluid 0, draw box solid, the start point x0, y0, z0, 0.4, 0.7, sama je lah, 0.3. And then lepas the fluid, you can create the boundary, the wall of the tank. Okay, box fill, bottom left, right part ni, dia ada nanti lepas tu. Maksudnya, kalau you draw everything, takut dia tutup. So, you can draw only on the bottom, left, right, front, back. So, atas ni tak draw lah, dibiarkan boleh tengok. Di start juga kosong, X 1.6, 0.7, 0.4. So, dia kena imagine sikit lah. Yang ni. Tapi ini untuk awal je lah. Nanti bila pakai FreeCAD tu lagi senang. You just call the FreeCAD punya dimension, terus masuk saja dimension dia. Ini untuk just in case you nak lukis 4 segi je, tak payah pening-pening nak panggil FreeCAD apa lah, just tulis je. Okay. Firebox cylinder list. Ni tak payah. Ni kalau nak combine drawing setting. Okay, so draw mode dia kat sini ada set draw mode dia. Dia ada kat sini nampak ada tulis full kan, mode full, draw mode dia full ada, ini ada draw mode full. Okay. Full maksud dia everything here dia akan draw full. Maksud draw full ni dia ada wire only on the boundary. Kalau face only face saja dia draw. Solid everything. Full the face and also solid combined together. Kalau in our case here, if we set draw mode equal to full ni, maksudnya dia both including face and solid kena particle akan masuk. Tapi tak, particle tak masuk ni, baru dia lukis. Particle masuk dekat box field ni. So kat sini dia bagi tahu define the draw operation to create VTK file. So kalau main list set shape mode, cari kat sini set shape mode kat mana? So dekat line 23 set shape mode DP bound set shape mode. Maksud dia DP dia adjusting coordinate to DP. Maksud dia coordinate dia tu dia akan adjust ikut DP ni. Sebab kadang-kadang tu kalau besar sangat dia akan adjust automatic lah. Actual using real coordinate. Kadang-kadang kita ambil DP ni sebab senang, sebab kalau you change resolution dia terus adjust dia. Okay. So yang ni dia banyak lukis lah. First, you see inside here, the draw box, and then the draw box lagi, and then the draw another box, and then last kali got another box. So ada banyak box lagi. Sebab apa? Tengok. Okay. So probably they create another box, here another box, and of course for the fluid itself pun another box. So first dia lukis dulu the boxes, and then baru they define which one is fluid, which one is boundary, which one is need to be full wireframe. Full, solid, ini only that. File building, ini file building. Okay, so here same here, you see file box, file building, set shape mode, draw prism. Ini lain. Terang. Okay, tak boleh. Tak boleh. Tak best. Okay. Okay. So I will only tell you benda yang important je. Ni kalau nak lukis line, ni pun tak perlu, tak apa. Nak lukis triangle, same je. Saya tadi lukis box, ni lukis lines. This one nak lukis triangles. Okay. Ni kalau nak cantumkan triangle, so basically benda dia sama je. You draw using the concept draw. Yang ni dia draw box. This one is draw triangles. Draw box, ini draw box, draw box. So I think it's better kalau nak fahamkan, dia tengok draw box ni, dia tengok kat mana point dia start. Ni size dia start at 0, meaning that dia beritahu okay, ini adalah probably dia punya boundary. Ni pun starting from 0. Yang ni start at 0.9. This one pun start at 0.9. Tinggi berapa? Start from kosong, tinggi dia 0.45. Ni tinggi dia 0.45. So this is probably the building tu lah yang akan berdiri langgar 0.45. Pada lebih tinggi daripada the main box tu. Main box tu is 0.3 saja. 0.4. Fluid 0.3. So nak tahu kat mana fluid, sini MK fluid, bawah dia lukis draw box. Saya ulang lagi. Sini boundary, maksudnya this is not fluid. So MK they put level 0, so they draw a box here starting from 0, size 1.6. Shape out the box. And then dia buat lagi draw box starting 0.9. And then boundary. Oh, void. Void maksudnya dia kosongkan the area. It's like you buat panjang and then you put, you nak only you want half aja, so you put void half to start from that. So tinggal dah paruh saja. Meaning that if you do this first step, the third step akan overlap yang first step lah. Kalau first step kalau you lukis this panjang, and then the next step you cakap void here, so tinggal separuh lah. Max dengan minimal ada limit ke? Tak ada limit. As long as tak berat, you boleh ubah. Okay. So I think kita fokus this first case dam break dulu. You go through the XML guide and then you cuba fahamkan apa maksud different line. I think that is better. Okay. So we can discuss next week. Yang ni geometry lah, box solid. So everything ada dalam XML file. Dia beritahu draw box ni apa? Draw a box with initial point and size. Box fill tu apa maksud dia? Indicate if solid or face and the face to be hidden. Tadi kan dia beritahu sini top, left, right, front, back. So dia kat sini top, left, front, back to be hidden. Cuma tinggal right and bottom saja. Okay. And then ni semua geometry, different geometry. Kalau you nak buat apa ni, rebatment, you want to put this shape. So either you can use cat or you can letak point one by one. Draw prism. Prism lagi. Ni mask. Kalau you nak hidden certain face, because kalau you draw macam ni, orang tak boleh nampak what happen inside kalau you nak ada. So you can choose a face that you want to hide. Okay. Macam ni case ni. So kalau you nak buat wave maker, kalau you put everything, dia akan tutup terus. Dia tak boleh nak nampak lah air dalam ni. So you can choose to hide the mask. 1, 2, 6, 7. 1, 2, 6, 7 will be hidden, and 5, 4, 3 saja akan ada, tapi tak bermaksud air itu akan melimpah. No, it just will hit height. Tapi, and then you can put your water here. Okay, so I think for next week you can try case dam break punya definition. We'll discuss on case constant definition here up until tak masuk execution lagi. I want you to go through every line ni dan cuba fahamkan apa maksud shake mode apa, set draw mode apa. Because if you tak use complex, better you just do case saja. Tapi kalau you rasa you will use complex geometry, then kita akan pakai FreeCAD. I think that will be, kalau requirement tu draw satu-satu batu you can draw one by one and then you can place it, the location. Tapi kalau you draw one by one, you just copy paste je lah, tukar je location dia. You can put dia punya location and dia punya kedudukan dia, you can turn dia. Tapi macam tu lah yang kita tunjuk. First start dengan put rectangular dulu. Rectangular, you assume as revetment. Once you dah run everything, dah nampak cantik dah, the hydrodynamics pun nampak cantik semua, radiometry, and then you upgrade. You go tukar the rectangular shape tu into revetment, proper revetment. But better to make your setup tu solid dulu, and then baru you move to complex punya dimension. So kita tak nak pening-pening, kita buat chill-chill je. So next week we'll discuss on dam break, so you tengok, so you can understand the layout of the XML file, and then we go to the execution and how to run the dam break. Okay, and then after that, how to do the post-processing to extract at different location. Okay, any question? It's okay kalau betul, kalau saya nak ajar you guys untuk run terus program, tapi bagi saya it's better untuk faham from the foundation, meaning that takut nanti you just run je, then something error happen, you not sure kat mana. So better you faham betul-betul how the file input works, and then in the future if you change something, ada problem, and if you want to discuss in the forum DualSPHysics, you know what to discuss with other person. Ada person tu cakap, okay, maybe your XML file ada problem, error, so you know where to refer. Okay, so I think that's all for today. We're not going to take long. This is like every week 1 hour session only. Once we masuk the example, then we try to do lah 1 class ke apa ke hours. Okay, no problem that I stop presenting. We hope you guys can have a revision, study the XML file, and we will discuss again next week. Okay. Okay, thank you so much. Okay. I stop recording.